Alright, so today we're going to talk about Le Chatelier's principle. Le Chatelier's principle tells us that if we add a stress to a system at equilibrium, the system will shift in the direction to relieve the stress. Okay, so we have a system that's already at equilibrium, and so if we add a stress to it, it has to go back to equilibrium. So I like to sort of think about a seesaw when we think about these, right? And at equilibrium, your seesaw is perfectly level. Okay, and then we all know that if somebody gets on one end of the seesaw, right, then the seesaw gets heavy, right, and is unbalanced. Okay, and so I like to think of this as the reactants and this is the products. Okay, and we think about our shifting in terms of a seesaw. Alright, so if the reaction shifts to the right, it will increase the concentration of the products and therefore decrease the concentration of the reactants. If it shifts to the left, right, it will decrease the products and increase the reactants. Okay, so again, reactants are on the left side and products are on the right side, just as they've always been before. Okay, so if we add a chemical, the shift will be to the opposite direction because you will have increased one side. Okay, so it will shift to the opposite direction of the side you added the chemical to. Okay, if you remove the chemical, it will shift to the same side. Okay, now if you increase the temperature, okay, it too will shift to the opposite side of heat. Okay, and then if you decrease the temperature, it will shift to the same side that has the heat. Okay, and then if we increase the pressure, right, increasing the pressure, remember, decreases our volume, and therefore will shift to the side of the least moles of gas. Least moles of gas, because aqueous solutions are not impacted by changes in pressure. Only gases are. So if we decrease our pressure, we increase our volume, thereby we have more space that we can fill with our gas, and so we can contain more, we have more gas, so it would go to side with more moles of gas. Okay. Now if we add a catalyst, we will have no shift. Okay, and again, that's because a catalyst increases the rate of the reaction. And we talked about with equilibrium that the rate of reaction in the forward direction, the rate of reaction in the reverse direction are equal. And so if we lower our activation energy, if we think about our potential energy diagrams, right, and we lower our activation energy by adding that catalyst, we have lowered it in both directions. If we go from reactants to products, or if we go from products to reactants, it is still lower than it was before. And so the rate of reaction in both directions has sped up equally. Okay? And so therefore there's no change in the equilibrium. The equilibrium situation will stay the same. Alright, so let's look at an example. So in this problem, if we add the hydrogen, and if you think about a seesaw with your pen, right, we add hydrogen, what happens to our seesaw, right? It gets heavy because we added more. So we have to shift to the side to relieve the stress, to get back to our even seesaw, right? So it's going to shift to the right. Okay? So this shifts to the right, and if it's shifting to the right, then our product concentration is increasing, and our reactants are decreasing. Okay? Now what happens if we remove nitrogen? Again, what happens if somebody jumps off your seesaw, right? This end goes flying up, right? And everybody else over here hits their butt on the ground. Okay, so this end goes up. How do I get it back to equilibrium? Well, it has to shift back to the left side, right? So you make it go down. Okay? So it shifts to the left, thereby decreasing your products and increasing your reactants. Okay? Now our temperature. Here it tells us our delta H is negative, and so that means our heat is a product. Okay? So exothermic heat is a product. Okay? Exothermic means heat is being produced, right? So it's a product. Endothermic would mean that heat is a reactant. Okay? Because it would be you have to add it to the beginning of the reaction. Okay? So again, same thing with the seesaw. If you increase the heat, right? We're increasing the side that heat is on, so that's getting heavier. So it has to shift this way in order to get back to equilibrium. So again, we're going to shift to the left. Okay, and that's going to decrease our products and increase our reactants. Now if we increase the pressure, you can notice here they're all gases, right? And we said we increase our pressure, that has a decreasing effect on our volume, and therefore we can't fit as much stuff. So it's going to go to the side with the least moles. Now this one is not really a seesaw shift, okay? It's just a one-time shift. Okay, so if you increase your pressure, you go to the side the least moles of gas. So if we increase our pressure, what side is our least moles of gas? So here I have 1 mole of N2 gas and 3 moles of H2 gas, right? So that means I have 4 moles of gas on this side. And over here, we have 2 moles of gas on the product side. So I'm going to side the least moles, so I'm going to shift to the right. And that's going to increase our products and decrease our reactants. Okay. And then if we add a catalyst, as we said before, that increases the rate of the reaction in both directions the same, and so there is no shift. There is no shift, and then these would stay the same, right? They would stay the same. They would not increase or decrease. Okay? They would stay the same. Right? This concludes the video for today.